Welcome! In this series of short videos, we will look at topics common to both the PowerBasic console and Windows compilers. Today we will look again at queue handling within your applications by using a queue collection to store arrays. This was the code we used in our last video on queue collections. We had created a queue collection and had put a number of strings into the queue. We had then gone ahead and extracted each of these strings from the queue in the order they were placed in the queue. However, since the data we're putting into these queues are all variant variables, we did allude to the fact that you could store other types of information within your queue, for example arrays, and that's what we're going to look at today. So let's clear down this code to the basics and start to put some new code in. So in our code we are still declaring a local variable called collection as an IQ collection. We're then using the let command to make that collection equal to the class queueCollection. That is our variable all set up to handle our queue collection now. And we're creating a new variable to count the number of items in our queue. And we're going to make use of the macro at the bottom of our code called countItems to count the number of items in our queue and to display this on our log. So if we run our code now, we will see it's quite correctly showing that there are 0 items currently sitting in the queue. So if we're going to add some data into this queue, we'll need to create a variant variable to hold our information. And we'll call that item input, declared as a variant. Now we want to create an array to add to this queue. So we've declared a local array, which is a single dimension array from elements 0 to 4. In other words, it's going to hold 5 pieces of information. We are then assigning one letter to each element of our array, the letters A, B, C, D, and E. We can then populate this variant variable with our array using the let command, quite simply by the name of the variant variable equals the name of the array and 2 brackets. Having populated this variant, we can now place it within our queue, exactly as we did in the previous video by using the collection.enqueue. So having put one array into the queue, can we now put a second but different array into the same queue? So we've now dimensioned a second array called data next. This again is a single dimension array from 0 to 2, therefore it will hold 3 elements. We are then populating the 3 elements with A1, B1 and C1. Again, we're populating our variant variable with the name of the array and adding it to the queue using the enqueue method. So we can now count how many items we've got in the queue, which should return the value of 2. Which it does. We now have 2 items in the queue. So let's now see if we can extract the data from the queue. So in order to extract the data from the queue, we're creating an item variant variable to hold the data coming back from the queue. We've created a new output array to put that data into, and a counter for each row in the array. It's important when you dimension that array to mark it as the name of the array, open bracket, 0, close bracket. This allows the array to be overwritten by what's coming back out of the queue. So now we want to step through each item in the collection and pull the data out and populate our output. So we're creating a local item variable. This will be used for the item count. We're going from that equals 1 to the number of items in the queue, which we determined further up in the code using the macro. We're then populating the vitem variable using the collection dequeue method. And we can then test the variant variable that's been pulled back to make sure it's not empty using the inbuilt variant vt command. However, what we're going to do now is we're not going to assume that all the data within the collection queue is actually all arrays. There may well come a time within your application when you want to store a variety of information within the queue. Some may be dynamic strings, some may be numbers, and some may be arrays. So we can use the variant vt command to work out what kind of information is stored within this variant variable, and we can act accordingly. So we're going to use the select command to work out what kind of information we're looking at. As the variant vt command returns a number, I'm first going to push this number out to the log to report on what kind of variant type it is. So if we run that code as it stands at the moment, we'll see that the two items that we have in the queue are both of variant type 8200. If you have a look in the PowerBasic help, you will see a list of equates that tells you what kind of information is actually going to come back in one of these variants. And you'll also see that the value 8200 is not on the list. This is because for a string array, it's going to be a combination of two of these values. So we can set that up in our code quite neatly by putting in a case statement. In this case, we are looking for the string and array. So we're pulling back something that is both an array and also an array of strings. So our next line of code is captured in a try-catch block. We're using the let command to populate our output array with the data that exists in the variant which we've pulled back from our collection. That quite simply dimensions and populates our array automatically. And then, like any other array, we can then step through the array from the lower bounding to the upper bounding of the array and push that information out to our log. So if we run that code now, we will see we have our two arrays. The first array with 5 elements between the letters A and E, and the second array with the values A1, B1 and C1 in a single dimension array of 3 elements. So we have successfully populated a collection queue with 2 separate arrays. We have then pulled that information back from the queue into another array and displayed it on our log. So that's very useful, but how can we prove that the variants aren't just pointing to the original arrays which are set up within our code? If we look back to our code, we have an array we set up called data next, which has 3 elements in it. We then put that into the queue. What happens if we reuse that array for some other purpose and put different data into it? So we've now assigned different sets of data to the same named array. So it should be using the same area of memory to store that and should have overwritten the data that was originally in that array. So having repopulated this existing array with different information, let's now add it to the queue. And having added it to the queue, let's run the application again and see what information we get coming back. And there we have our information coming back. The first array is coming out correctly, as is the second. And the third array, which was using the same array name, is coming back with the information we put into that. So it's not using the original array at all. The information going into the queue is handled quite separately, even if we are continually reusing the same array. So using this approach, it's quite possible to put different types of information within our queue. We have so far put 3 sets of arrays into our queue. What happens now if we want to add a dynamic string item to the queue? As we did in our previous video, we merely have to populate our variant with a dynamic string, in this case the words apple pie. We then have to use our enqueue method to add that to the collection. So we now have 4 items in the queue, 3 arrays and a dynamic string. If we go down to our code where our case statement is testing the type of variant we've got back from the queue, we can add 2 more case statements, one to test for dynamic strings. In this case, it will use the variant $command to turn what's in our variant variable into a string so we can display it to our user in the log. And if there's any other type coming back from the collection, we can display a simple message. If we try running that code now, we will see we're getting our 3 arrays as we were before coming back from the collection, plus we have our variant type 8, which is our string data. And it's displayed on the screen simply as data equals apple pie. So in summary, we can see using this method that you can put different types of information as variants into our collection queue. We can then pull the information back one item at a time and display it or use it within the application. This allows the collection queue to be very flexible indeed. You can use such queues to keep track of information within your application, for example, on a list of computers to actually poll for information. Once you have contacted the computer, you can put them back at the end of the queue. There are, however, some limitations to putting arrays into collection queues. The help file that ships with PowerBasic does say there's a limit to the number of dimensions such a queue can actually handle. In my time in programming, I've used a great many single-dimension arrays. I've used many more two-dimensional arrays, a small number of three-dimensional arrays, and once I've used a four-dimensional array. The maximum number of dimensions a collection queue can handle is 8 dimensions. I can't honestly conceive a need for an array that has 8 dimensions, but that's the limit that the queue collection can actually handle. So as a limit, I think it's high enough up the scale that you may never encounter it. Hopefully you'll find queue collections useful in your applications, but that's it for today. Thank you for watching.